All right, hello everybody. Let's continue with our graphing quadratic functions here. We're just going to talk about some properties and graphing some functions, mostly in general form as opposed to just being in vertex form. But it can work either way. You just have to convert to the other form if you wanted to. But basically, the idea, you get a parabola, right, which is the graph of a quadratic function. And it's going to do something like that. The key features, things we're going to need, of course, are the vertex. We're going to show how to find that. So in vertex form, that's very easy to see, but in standard or general form, it's not. We're also going to look at the x-intercepts. Okay, many graphs, many parabolas have two of them. Some have one. Some don't have any. Okay, you may recall when you solve equations equal 0. Some of the answers are imaginary numbers, right? So those just aren't going to show up on the graph. We're going to see the y-intercept, okay, which in this problem is probably pretty close to the vertex. We'll figure out how to find that. And then directly related to the vertex, of course, is the old axis of symmetry, right? So if you know the vertex, you kind of indirectly know the axis of symmetry as well. So let's take a look. Let's go through a couple examples here and then see how this all fits together. Okay, so here's a sample equation, x squared, y equals x squared minus 4x minus 5. Okay, so some things that we kind of know is, it's going to be a parabola opening upward because the a value is positive. And that's kind of really all we know at this point, right? Okay, so let's go through a few things. You can actually find the vertex, and we can do this without even being in vertex form. Okay, and here's a little trick. The x value, here's like kind of a formula thing. So the x value there will always be, if we recall when we did standard form or general form with quadratic formula, we had ax squared. Oops, I'm trying to erase here. We did ax squared plus bx. Sorry, give me one sec. Struggling with the technology for a sec. There we go. We had things set up in this form, ax squared plus bx plus c, right? And we would set them equal to 0 and be able to solve. The a, b, and c can be used actually to find the vertex. Okay, there's a little formula for the x coordinate will always be the opposite of the b value over 2a, negative b over 2a. And while I'm thinking about it, let me just point this out. If you guys remember that quadratic formula from before, which finds the zeros, right? Remember how that was negative b plus or minus square root b squared minus 4ac all over 2a, right? And if you notice that this part of it, okay, is what's going on right here. Okay, that's going to give you it's going to be like the center of the graph. If you think about the vertex, okay, down here, it's going to be the center of the graph, okay? And technically, the x equals negative b over 2a will actually give you the equation of the axis of symmetry because it's going to be a line. But we're using this first to find the x coordinates of the vertex. Okay, so let's just do that for this example. So the opposite of b over 2a, okay, in our problem, the b value up here is negative 4, so the opposite is positive 4 over 2 times the a value. Okay, a value is 1. So this is, of course, 4 over 2, which does reduce to 2. Okay, so we know the x-coordinate of our vertex is 2. And then to find the y-coordinate, we can just plug in that x value. So we would do y equals, I'm plugging in 2 for the x, so 2 squared minus 4 times 2 minus 5. Okay, and again, I just plugged that into the equation, right? We knew an x value. I'm just trying to find the y value that goes with it. So 2 squared, of course, is 4, minus 4 times 2, which is 8, minus 5 more, which gives us a value of negative 4 minus 5, so negative 9. Okay, so we know that our vertex for this graph, the x-coordinate, I don't know what just happened. The x-coordinate was the 2 that we found first, and then we plug that in to get the y-coordinate. So we're able to find that algebraically. Okay, we didn't really have to use a calculator or Desmos or anything. or convert to vertex form if you don't want to. And we're able to get that right away. Okay, so that tells me, and I'm just going to draw this as a rough sketch, 2 and down 9. Okay, we have a vertex down here. Okay, in this case, it is a minimum because the graph opens upwards. So the vertex is going to be the bottom point, so the graph can open up. Okay, a couple other things we can find, or we can do graphically. We can find the y-intercept. Okay, the y-intercept, if we're in this general form here, is just simply the c value. Okay, so the c value meaning, in this case, the -5 there, that's going to be the y-intercept. So in this case, -5, 1, 2, 3, 4, 5, that's going to be the y-intercept of the graph. Okay, so that's kind of useful, right? We can just find the c value. And the reason that works, because if you think about y-intercept is the y value when x equals 0. So in this equation that we were graphing, in this function, if the x were 0, both x's were 0, it would just be 0 squared minus 4 times 0, which is all 0, and then, then there'd be a -5 there still. Okay, so that's the y-intercept. Now if we want to find the x-intercepts, okay, and this will be the last thing we need to find. To find the x-intercept, we're trying to figure out what happens when y is 0. Okay, so the function y equals x squared minus 4x minus 5. Okay, I'm going to try and move this all up a little more. Okay, if we set the, like I said, set the y value equal to 0, we end up just getting this equation, 0 equals x squared minus 4x minus 5, which is one of the things that we were doing a couple chapters ago where we solved quadratic equations, right? We had factoring as an option, okay, which this one should be factorable. We do have factors of -5 that add up to -4 if we were to use x minus 5 and x plus 1. Okay, and then the zero product property would say that x would either equal 5 or x would equal -1. Okay, those would be like solutions to the equation. Those are also the zeros of the function, okay, or x-intercepts. They mean the same thing. Okay, so we know we have one at -1. There's an x-intercept, right? The y equals 0 there. And also when x equals 5, y equals 0. Okay, and then we could just simply draw our function through there. We know we got a 0 there, and we got a y-intercept, then a minimum, and then it's going to come back up. Okay, so it's not a perfect graph, but we got a lot of the key features. We got the vertex on there, which is probably the biggest feature. We got the y-intercept, and then we got the x-intercept. The last thing that we could add would be the axis of symmetry here. Oops. Axis of symmetry would be coming right up through here. And remember, what we actually found at this very step over here, when we found the x-coordinate, that is going to be the axis of symmetry, because it's just going through that x value. Okay, so we can do a lot of stuff. Some of them are not going to be as nice. So, calculators and decimals and stuff like that can be used a lot. But certain problems can definitely be done without. If you're taking an SAT and there's a no calculator portion, you're going to want to know some of these little properties and stuff. So let's walk through one more and see one that's just slightly more complicated. But that's kind of the concept, if you can remember those little formulas and steps there. All right, so example 2, we have y equals -3x squared plus 8x plus 16. Okay, so let's do some of the same things. Let's try and find out the axis of symmetry and the vertex. Okay, so again, we're going to start out by doing that little formula. The x-coordinate is going to be the opposite of b over 2a. Okay, so in this case, the opposite of b is going to be -8 over 2 times the a value of -3. So -8 over -6, okay, which if we want to reduce, could be 4/3. Okay, so that's the x-coordinate. Then the y value is going to be what we get when we plug that in. Okay, so we're going to do -3 times 4/3 squared plus 8 times 4/3 plus 16. We're going to see what that gets us. All right, so let's do some calculating fun here. So -3, so 4/3 squared would be 16 over 9 plus, so 8 times 4/3. If we throw a 1 under there, right, would get us 32 over 3 plus 16. All right, so let's see what we got. If we keep doing this here, I could throw a a 1 under there. I'm just trying to do some of this stuff without a calculator, just as a refresher. So the -3 times 16 over 9, I can reduce the -3 over 9 to -1 over 3. And then we would have -1 times 16 over 3 plus 32 over 3. I know I'm going to need to add these, so instead of writing it as 16, I'm going to need to write that as 48 over 3. Right, just getting ourselves that common denominator so that we can combine these all nicer at this step here. So then we would have -16 plus 32, okay, which is 16 plus 48 is going to be 64 over 3. Okay, so of course you're going to have calculators available pretty much anytime we're doing this kind of stuff, but just in case, you ever find yourself out there, need to find the y coordinate and you don't have a calculator, you're just at a party or something and someone asks you for the vertex, this is how it works. Okay, so we got that stuff. Okay, we got our vertex x and y values. Okay, let's get a little idea of what this thing's doing. It's going to be opening downward, right, because we do have a -a value. So since the graph opens downward, we know that the vertex is a maximum in this case. And again, the coordinates would be as we just had before, an x value of 4/3 and a y value of 64/3. All right, so we also kind of know then that the axis of symmetry, remember, is always just going to go right through the vertex. So the old AOS, axis of symmetry, will just be x equals that x coordinate of 4/3. Okay, other things we can find then are the x and y intercepts. So if we want to find those, let's start with the y-intercept. Let's do the easy one first, right? The y-intercept, again, is just going to be the c value from the graph. Okay, so the y-intercept of 0, 16. So we could plot that to get a little more accuracy. Now the one that involves a little bit of work is going to be our x-intercept, which is going to be what we get when we plug in 0 for y. Okay, so if we set the whole equation equal to 0, okay, instead of y equals, we'll make it 0 equals -3x squared plus 8x plus 16. Okay, and again, this is going to go back to some of the old methods that we did previously. Now, it may very well be factorable, doing the 3 times 16 method and trying to split up the middle term, and that's fine if you want to do it that way. But let's just do as a review as well that the quadratic formula always works. Okay, so let's just review that since that's kind of a guaranteed to work method. All right, so we're going to say x is going to equal the opposite of b plus or minus square root of b squared minus 4 times a times the value of c all over 2a. All right, and we need to do some simplification. Okay, so let's see what we got. Try and move some of this stuff out of the way. All right, so when we start to simplify this stuff, we are getting the -8 plus and minus the square root. So under that square root, that discriminant value, the 8 squared minus 4 times -3 times 16 is 256. Okay, and the whole thing's over -6. Now the square root of 256 is 16. Okay, so I'm going to work this way here where I have some room. So -8 plus or minus 16 all over -6. Okay, so that's going to give us two cases. -8 plus 16. Okay, I'm trying to get this all on one page. -8 plus 16 over -6, and also -8 minus 16 all over -6. So if we simplify those and get some answers here, The negative 8 plus 16 is 8 over negative 6, which is negative 4/3 reduced. Okay, and then the negative 8 minus 16 would be negative 24 over negative 6, which when we divide equals 4. Okay, so to kind of complete the process here, our x-intercepts are negative 4/3 and positive 4. Okay, so if we want to take a look at a graph in the next page just to kind of confirm everything that we did here, we can do that. So let's take a quick look. Alright, so magically here's a graph here. Let's confirm everything. So first thing we did up here was our vertex. We can see we got the negative 4/3 and 64/3. I'm sorry, positive 4/3 and 64/3. We can see that's just the decimal version. Y-intercept we said here in green in the middle there was at 0.16. Again, that's just the C value, so that's easy. And the x-intercepts, which was the last thing we did with the quadratic formula, we can see on the graph there was one at positive 4, and then the negative 4/3 is shown as a decimal. Okay, so you can really do a lot of this stuff without a calculator. They do sometimes get messy, obviously, but it is definitely doable. Okay, so that is that, and that is what you need to know.